Chapter 7. Fractions. We will learn different types of fractions, comparing fractions, fractions in lowest terms, representing a fraction on a number line, addition and subtraction of fractions, multiplication of fractions, division of fractions. I hope you know about improper fractions. I know about proper fractions as well. I can add up and subtract them easily. Different types of fractions. Let us revise whatever we have learnt about fractions till now. Fraction is a part of a whole. There are different types of fractions. Proper fractions are those fractions in which the denominator is greater than the numerator. Example, 9 upon 17, 8 upon 16, 7 upon 11, 3 upon 4, 2 upon 3. Fractions in which the numerator is greater than the denominator are called improper fractions. Example, 8 upon 7, 13 upon 11, 21 upon 9. Mixed fraction. A fraction consisting of a whole number and a fraction is called a mixed fraction. Thus, a mixed fraction has two parts, a whole number and a fraction. Example, 3, 1 upon 5, 5, 2 upon 7, 6, 1 upon 3. 29 upon 6 is an improper fraction. To convert it into a proper fraction, we divide 29 by 6. Divide the numerator by the denominator to get the quotient and remainder. So, in 29 divided by 6, quotient is equal to 4 and remainder is equal to 5. Then, the quotient is the whole number part and the remainder over the denominator is the fraction part of the mixed fraction. Therefore, 29 upon 6 is equal to 4, 5 upon 6. Fractions having the same value are called equivalent fractions. To obtain the equivalent fraction of a given fraction, we have to multiply the numerator and denominator of the fraction by the same number. Example, write 5 equivalent fractions of 1 upon 4, into 2, into 3, into 4, into 5, into 6. Numerator 1, 2, 3, 4, 5, 6. Denominator 4, 8, 12, 16, 20, 24. Equivalent fraction of 1 upon 4, 2 upon 8, 3 upon 12, 4 upon 16, 5 upon 20, 6 upon 24. There is an interesting fact about equivalent fractions that can be used to check whether two fractions are equivalent or not. Numerator of the first fraction into denominator of the second fraction is equal to denominator of the first fraction into numerator of the second fraction. Example, check whether 3 upon 7 and 9 upon 21 are equivalent fractions. Fractions. Numerator of first into denominator of second. Denominator of first into numerator of second. 3 upon 7, 9 upon 21. 3 into 21 is equal to 63. 9 into 7 is equal to 63. Products are equal. Therefore, the two fractions are equivalent. Comparing fractions. To compare two fractions having same denominator, like fractions, we simply compare the numerators. The fraction with the greater numerator is greater. In like fractions, the denominators are equal. In both fractions, the whole is divided into the same number of equal parts. The fraction having a greater numerator will be greater. Example, compare 5 upon 9 and 8 upon 9. 5 upon 9, 8 upon 9. It is obvious from the figure that 5 upon 9 is less than 8 upon 9. To compare two fractions having same numerator, we simply compare the denominators. The fraction with the lesser denominator is greater. Example, compare 3 upon 7 and 3 upon 11. It is obvious that 3 upon 7 is greater than 3 upon 11. Example, compare 4 upon 6 and 7 upon 12. Solution, LCM of 6 and 12 is equal to 12. Therefore, 4 upon 6 is equal to 4 into 2 upon 6 into 2 is equal to 8 upon 12. There will be no change in 7 upon 12 as the denominator is already equal to 12. 8 upon 12 is greater than 7 upon 12. That is, 4 upon 6 is greater than 7 upon 12. Fractions in lowest terms. Fraction in the lowest terms mean reducing a fraction. Reducing a fraction implies simplification of a fraction. The highest common factor between the numerator and the denominator in a fraction in the lowest terms is equal to 1. Step 1. Calculate the HCF of the numerator and the denominator. Step 2. Divide both the numerator and the denominator by the HCF to get an equivalent fraction of the given fraction. Example, reduce 30 upon 36. Solution. Step 1. Factors of 30 is equal to 1, 2, 3, 5, 6, 10, 15, 30. Factors of 36 is equal to 1, 2, 3, 4, 6, 9, 12, 18, 36. Common factors of 30 and 36 are 2, 3 and 6. HCF is 6. Step 2. Therefore, 30 upon 36 is equal to 30 divided by 6 upon 36 divided by 6 is equal to 5 upon 6. Representing a fraction on a number line. Fractions can be shown on number lines to represent 1 upon 2 on the number line. Draw the number line and mark 0 and 1 on it. Divide the gap between 0 and 1 into two equal parts. The point in the center represents 1 upon 2. 0 upon 2, 1 upon 2, 2 upon 2 is equal to 0, is equal to 1. To represent 1 upon 3 on the number line, the gap between 0 and 1 is to be divided into three equal parts. The first point from 0 represents 1 upon 3 and the second represents 2 upon 3. 0 upon 3, 1 upon 3, 2 upon 3, 3 upon 3 is equal to 0, is equal to 1. Addition and subtraction of fractions. Addition of like fractions. The denominators of like fractions are the same. Therefore, the numerators can be added directly. Method 1. Method 2. Addition of unlike fractions. The denominator of unlike fractions are different. The denominators have to be first made equal and then we can add the fractions. Step 1. Convert mixed fractions into improper fractions. Step 2. Calculate the LCM of the denominators. The LCM is the new denominator. Step 3. Multiply the numerator and denominator of the fractions to be added by the appropriate numbers so that the denominator of all the fractions is the same. That is, the LCM of the denominators. Step 4. Add the fractions. Step 5. If the sum of the fractions is an improper fraction, then it has to be converted into a mixed fraction. Example. Add 4. 2 upon 3 plus 5. 3 upon 4. Solution. Step 1. 4, 2 upon 3 is equal to 4 into 3 plus 2 upon 3 is equal to 14 upon 3. 5, 3 upon 4 is equal to 5 into 4 plus 3 upon 4 is equal to 23 upon 4. Therefore, 4, 2 upon 3 plus 5, 3 upon 4 is equal to 14 upon 3 plus 23 upon 4. Step 2. The LCM of 4 and 3 is 12. To make both the denominators same, we multiply the first fraction numerator and denominator by 4 and the second fraction numerator and denominator by 3 is equal to 14 upon 3 into 4 upon 4 plus 23 upon 4 into 3 upon 3. Step 3 is equal to 56 upon 12 plus 69 upon 12 is equal to 125 upon 12 is equal to 10, 5 upon 12. Step 4 and 5. Subtraction of like fractions. To subtract fractions, the following steps have to be followed. Step 1. Make the denominators equal. Step 2. Subtract the numerators. Step 3. If required, simplify the fraction. The denominators of like fractions are the same. Therefore, the numerators can be subtracted directly. Example. Subtract 3 upon 8 from 7 upon 8. Solution. 3 upon 8 and 7 upon 8 are like fractions. Therefore, we can subtract the numerators directly. Is equal to 7 upon 8 minus 3 upon 8 is equal to 7 minus 3 upon 8 is equal to 4 upon 8. 4 upon 8 can be reduced further to 1 upon 2. Example. Subtract 2 upon 3 from 7 upon 8. 2 upon 3 and 7 upon 8 are unlike fractions. Their denominators are not equal. Step 1. Make the denominators equal. We have to calculate the LCM of 3 and 8. LCM of 3 and 8 is equal to 24. The denominator in both the fractions has to be 24. Multiply the numerator and the denominator of both the fractions by appropriate numbers to convert them into fractions with denominator equal to 24. Therefore, 2 upon 3 is equal to 2 into 8 upon 3 into 8 is equal to 16 upon 24. Similarly, 7 upon 8 is equal to 7 into 3 upon 7 into 3 is equal to 21 upon 24. Our fractions are now 16 upon 24 and 21 upon 24. Therefore, 7 upon 8 minus 2 upon 3 is equal to 21 upon 24 minus 16 upon 24 is equal to 21 minus 16 upon 24 is equal to 5 upon 24. Multiplication of fractions. Multiplication of fractions takes place in 2 steps. Step 1. The numerator is multiplied with the numerator. Step 2. The denominator is multiplied by the denominator. Example 1. Multiply 6 upon 7 by 2, 5 upon 9. Solution. Convert 2, 5 upon 9 to an improper fraction. 2, 5 upon 9 is equal to 23 upon 9. 6 upon 7 into 2, 5 upon 9 is equal to 6 upon 7 into 23 upon 9 is equal to 6 into 23 upon 7 into 9 is equal to 138 upon 63 is equal to 2, 12 upon 63. Example 2. Multiply 35 by 1, 2 upon 5. Whole number 35 is equal to 35 upon 1. Therefore, 35 into 1, 2 upon 5 is equal to 35 upon 1 into 7 upon 5 is equal to 35 into 7 upon 1 into 5 is equal to 245 upon 5 is equal to 40. Properties of multiplication of fractions. Property 1. We can change the order of the fractions and the product will remain the same. Example. Note, when multiplying more than two fractions, we can use brackets. Property 2. When a fraction is multiplied by 1, the product is the fraction itself. Example. 7 upon 8 into 1 is equal to 7 upon 8 into 1 upon 1 is equal to 7 upon 8. Property 3. When a fraction is multiplied by 0, the product is 0. Example. 5 upon 6 into 0 is equal to 5 upon 6 into 0 upon 1 is equal to 0 upon 6 is equal to 0. So, we get to learn the following three properties. 1. Changing the order of fractional numbers does not change the product. 2. A fraction multiplied by 1 is the fraction itself. 3. A fraction multiplied by 0 is 0. Division of fractions. Dividing a fraction by fraction. Step 1. Write the reciprocal of the second fraction. Step 2. Multiply the second fraction by the reciprocal. Example. Divide 8 upon 12 divided by 1 upon 2. Solution. The reciprocal of the second fraction, 1 upon 2, is equal to 2 upon 1. Multiply 8 upon 12 by 2 upon 1. Therefore, 8 upon 12 divided by 1 upon 2 is equal to 8 into 2 upon 12 into 1 is equal to 16 upon 12 is equal to 1. 4 upon 12 is equal to 1 upon 3. Divide a whole number by fraction. Example 1. Divide 4 by 1 upon 3. Solution. 4 divided by 1 upon 3 is equal to 4 upon 1 divided by 1 upon 3 is equal to 4 upon 1 into 3 upon 1 is equal to 4 into 3 upon 1 into 1 is equal to 12 upon 1 is equal to 12. Dividing a fraction by a whole number. Example 2. 2 upon 9 divided by 3. Solution. 2 upon 9 divided by 3 is equal to 2 upon 9 divided by 3 upon 1 is equal to 2 upon 9 into 1 upon 3 is equal to 2 into 1 upon 9 into 3 is equal to 2 upon 27. Properties of division. Property 1. When a fraction is divided by 1, the quotient is the fraction itself. Example, 1 upon 2 divided by 1 is equal to 1 upon 2 into 1 upon 1 is equal to 1 upon 2. 2. 3 upon 4 divided by 1 is equal to 11 upon 4 into 1 upon 1 is equal to 11 upon 4 is equal to 2. 3 upon 4. Property 2. When any fraction is divided by itself, the quotient is 1. Example, 7 upon 8 divided by 7 upon 8 is equal to 1 upon 1 is equal to 1. 2. 1 upon 2 divided by 2, 1 upon 2 is equal to 5 upon 2 divided by 5 upon 2 is equal to 1 upon 1 is equal to 1. Property 3. When 0 is divided by a fraction, the quotient is 0. Example, 0 divided by 3 upon 4 is equal to 0 into 4 upon 3 is equal to 0 upon 3 is equal to 0. Property 3. A fraction cannot be divided by 0.